Alright, so, trying to zoom in. Alright, this is our roller coaster design. It's a bit of a mess because currently it's going under, like, kneading up or making it look nicer, but I just wanted to record my video. So, you start off with a turn. Let me get my stylus out. And a chain will pull you up, at which point we calculated the GPE needed, like the gravitational potential energy you'd gain from this, to figure out how much we'd need for the loop. And then when you went down, there'd be 12 meters between you and the ground. And that we calculated the kinetic energy. So for the first hill, we used the GPE formula, mass times gravity times height, and we got this answer right here. And then we plugged that in to what's the formula for velocity to figure out. Oh wait, sorry. We also found out the gravitational potential energy at the bottom, so we could subtract the two and figure out the kinetic energy. We used the kinetic energy to figure out the velocity by doing the kinetic energy over a half times the mass to get the velocity squared. And we did the square root. It came out to like 37, and then that gave us how fast it was going at the bottom of our roller coaster, or the beginning of the loop. And then we figured out the energy at the top of the loop, starting over here. Here's our free body diagram. And I believe, no, that's hill number 2. Calculations are over here. So we found out the GPE again, and we subtracted them, and we got our, this a mess. Yes, okay, yeah. We got our GPE, and then we subtracted them from the top. We got our velocity. Then we used our velocity over here to figure out the force net and the apparent weight. And then we got hill number 2. Hill number 2 all the way over here. Figured out our GP again, our kinetic energy again, same process as hill 1. Keep going, doing the same thing over and over. Found our net force and its apparent weight to make sure, our riders don't die of G-forces. Then we move on to hill 3, which is not these two hills, it's this hill right here. And we found out it's same thing as before. We found out it's GPE, etc. Then velocity. Then we went down over here and we figured out the net force and its apparent weight. And then, this was a tricky bit. We got to the end of our roller coaster and we had to figure out how to slow down. So we phoned up one of Michelle's friends and we got that the whole energy for the roller coaster is just the first the force gravity, and how to stop the car. She gave us a formula, we used it, and that was our acceleration to slow down, and the amount of friction to stop the car equals negative 29 meters a second squared. So yeah. Here's our roller coaster design. Yep. steep chop, loop-de-loop. It's very rough because we did our math all on the same page. Sorry about that. Hills to slow it down. Oh, I believe, yup, we have our updated roller coaster. Got your Tunnel of Terror, which is like where you start off, and then you got your little hills to slow down, and the end shed, which would be like over here. And yeah, that's it. Thank you.